Hi, good day to you all. Welcome to another physics class. So today we are talking about latent heat. Yes, we have started the topic, and I hope you enjoyed the previous class on latent heat. So now let's go, let's delve deeper. So we'll be solving more questions on latent heat. If you can remember when we talked about specific heat capacity, there is this equation I gave you that is heat loss must be equal to heat gain. Yeah. So the same thing is also applied here. I'm not saying there will be heat losses, heat gain all the time, no. But remember that the one gaining the heat and the one losing the heat are always equated. Now, it is also applied to latent heat. Yes, because you'll be wondering why is specific heat capacity coming into play. Yes, if the ice is melting, definitely it is turning its state to a particular state. When ice melts, it turns to water. It turns to liquid. Now, this change of states also brings about the lowering or increment in temperature. And therefore, there will be what? Heat loss and heat gained too. If the temperature was high before and later got reduced to a particular level, that means heat has been lost. If the temperature was at the lowest level and eventually became high, that means it is gaining heat. That's the basic principle under this topic. Now, look at this question. Calculate the quantity of heat required to melt 4 kilograms of ice. You remove the ice from your refrigerator or freezer. Definitely the melting process simply involves what? Increase in temperature. Because your ice will eventually turn to what? Liquid. So now here, first of all, let us write the parameters given to us. We have our mass as 4 kilograms. When the water is formed, it was formed at a particular temperature. That temperature is the final, which is 50 degrees Celsius. The initial temperature will be what? Temperature of the ice, which is at what? 0 degrees Celsius. Yes. Now, we are told to take the specific latent heat L as 3.4 times 10 raised to power 5, while the specific heat capacity C is 4.2 times 10 raised to power 3. Remember to put the unit, joules per kilogram per Kelvin. Is that understood? Now, the question says we should calculate the quantity of heat, the Q. So here, we are going to add up the two parameters given to us, which is ml, which is Q, equals to ml. I hope you understand this under the latent heat, and also plus mc change in theta. That is what we are going to add up. Let me adjust. Okay, so now that we have Q equals to ml plus mc change in theta, our mass is what? 4 kilograms. That will be 4 times, what is our latent heat? 3.4 times 10 raised to power 5 plus the same 4, specific heat capacity, 4.2 times 10 raised to power 3 times, what is our change in theta? That will be what? 50 minus 0. 50 minus 0. Did you get the illustration? Look at it well. ml plus mc change in theta. What is our ml? That is the 4 times this L. This is the L given to us, while this one is the what? Specific heat capacity. So having gotten that, let's use our calculator to move ahead. This one times this, what will it give us? We have a total of, okay, since 4 is common, we can just say 4 into brackets 3.4 times 10 raised to power 5 plus this. You do this one times 50 separately. Is that taken? Let me use the calculator. What do we have? We have 4 into brackets. Let's use law of indices. So here we have 2 things. 50 times this, 210 times 10 raised to power 3. So if you want to change that one to standard form, that 210, what will it turn to? So 4 into bracket 3.4 times 10 raised to power 5 plus 2.1 times 10 raised to power 5. 10 raised to power 5, 10 raised to power 5. So add this up. Sorry, I'm using mathematics because I couldn't get a calculator here. So we have 5.5 times 10 raised to power 5. Multiplied by 4, what do we have? 5.5 times 4, that should give us 220. 220 times 10 raised to power 5. Change it to a correct standard form. 10 raised to power 7. Because it is quantity, that is joules. Is that taken? Let me see. 5. That's 5. 2.1 times 10 raised to power 5. 5.5. Okay, no. This one should be 22. Sorry, not 20. So 2.2 times 10 raised to power 6. This 22 times 5. Okay. Do you understand? Look at the question. Take a look at the question very well. We're given the mass. Even from the question, you will know we have to use the latent heat as well as the specific heat capacity because it's changed its state from ice to liquid. So we're going to use the specific latent heat of the ice as well as the specific heat capacity of water. Since that's the solution form on the long run. Any question? So continue next class. Bye. Ciao.